Hey everyone, it's been a while since I've last made a video going from IA3 to now IA4. This is probably, I would say, even harder than IA3 given that we are combining three different topics: acids and bases, equilibrium, and redox. And given that these are some of the hardest topics in the year, I highly suggest you prepare as much as you can for this. Take advantage of this practice video, do some extra practice questions if you need, because this is going to be brutal. Hence why it's called the practice exam of death. Okay, so let's get started. Alright, number one asks, when a reversible reaction is at equilibrium, the concentration of the products and the concentration of the reactants must be blank. So this goes back to the definition of equilibrium, where when you're at equilibrium, both reverse and forward reaction rates are equal. So number one, equilibrium has two different types of traits. One of them is equal reaction rates, both forward and reverse. And then the other part, which the question is asking about, is that concentrations, they don't necessarily have to be equal, but they must be constant. So that's the other key thing about equilibrium. Concentrations are constant. Not equal, but constant. You can still have more products versus reactants, but as long as they're being made at the same constant rate, made and used at the same constant rate, then we have equilibrium, okay? Okay, for number two, here we have an ionic equation that's balanced, and we are looking at where the electrons are being transferred from. So when someone loses electrons, those electrons are gained by someone else. So first we need to identify who is losing and who's gaining. So let's look at here. So we start with Al3+. It goes from 3+ to 0. So I'm going to write that. So in this case, this is a gain of electrons because we become more negative. Where on the other hand, Mg goes to Mg2+. When you're becoming positive, you lose electrons because electrons are negative. So based on this, we see that magnesium loses electrons and aluminum 3+ gains those electrons. So the electrons go from Mg to Al3+. So that's where the electrons go. From magnesium to aluminum 3+, and that's choice 3. Number 3, phenolphthalein is pink in an aqueous solution having a pH of blank. If you use your reference table, I believe this is table M, I believe, with the indicators, you're going to see that phenolphthalein has a pH range of 8 to 9, where it goes from colorless to pink. So we're looking where phenolphthalein is pink. When it's pink, it's above the pH range. So it starts colorless below, and then once it hits somewhere in the middle of this range, above 9, it's going to be at pink for sure. So in that case, we're looking for a number that's above 9, and that is choice 1, 10. Number 4, which substance is an Arrhenius acid? So this goes to the definition of an Arrhenius acid or Arrhenius base. So the Arrhenius theory has acids that give H+, and then bases OH-. So they produce these things, these ions. So Arrhenius acid needs to have the H+. And that's choice 2, HBr. You could even see this on table K. That's where all the acids. And then for the bases, these are table L. Alright, number 5. Compared to a 1 liter aqueous solution with a pH of 5, a 1 liter aqueous solution with a pH of 7, So we're focusing on the solution with a pH of 7. 7 is more basic than 5, and so it's going to have less hydronium ions. When you're higher pH, there's less hydronium ions, and given that we are 2 pH units away, that means we differ by a factor of 10 to the second. Times different. So here our answer is going to be choice 2. Okay, number 6. When this equation is balanced, both Fe3 plus and Fe have a coefficient of blank because of how many electrons are being transferred. Okay. Now this is tricky because it's going to require us to look at the other substance, zinc. Zinc goes from 0 to 2 plus. In that case, that's 2 electrons being transferred to go from 0 to 2 plus. However, there are 3 zincs. So in total, we have 6 electrons being transferred. Now to go from 3 plus to 0, in order to match those 6 electrons, here one single of iron needs 3 electrons. But if we have 2 irons, then that number changes to 6. And that number changes also to 6 since we have 3 of them. And so it's choice 2. If we had 1 iron, it would only be 3 electrons. But since we have 2, we need 6 to also match the zinc, losing 6 electrons. Okay, number 7. For a reaction system at equilibrium, Le Chatelier's principle can be used to predict the blank. So when we're talking about equilibrium, we're talking about reaction shifts. Which ways are going to go, left or right? And this left or right shift is a result of a stress on the system. All these other choices don't necessarily relate at all to equilibrium. So it's just choice 3, the effect of a stress on the system. Number 8. Ammonia is produced commercially by the Haber reaction, given below. The formation of nitrogen gas is favored by what? So the formation means we are producing nitrogen gas. Number 8. Formation is same as produced, or a product. So we're looking for where NH3 or nitrogen gas is being produced. So in that case, N2 is a product for the reverse reaction, or the left shift. So for this question, we need to look for which stress will cause a left shift. So I'm going to use the ramp method to illustrate which way it's going to go. So an increase in pressure relies on us counting the number of moles of gas on both sides. So here we have 4 on this side, and here we have 2 on this side. If we increase pressure, we're going to go to the right side to favor the less mole side of gas. So that's shift. So it can't be that. It's a shift right. Decrease in pressure now goes the other way, going to the side with more moles of gas. So that's our answer. But let's look at the other choices. Removal of NH3 is also a shift right, because this lowers the reaction that way. Now the addition of H2 also lifts up the left side. It's also a right shift. And so that's why it's choice 2. Number 9. In terms of entropy and energy, systems in nature tend to undergo changes toward something with high or low entropy. So this is what we call a spontaneous reaction. The universe favors these 2 conditions. High entropy, that means a lot of chaos and disorder. And it also favors lower, more stable energies. In other words, we also call those exothermic reactions. So we can cross off 1 and 2 because those are low entropy. We need high entropy. And then we look at choice 3 because it also has lower energy. So that's what the universe favors. High entropy, low energy. Number 10. They give us a reaction and we are looking at the oxidation number of zinc and how it changes. So we need to look at zinc on both the left side and the right side. Given that zinc is a free element on the left side, it has an oxidation number of 0. And then, when it's bonded with sulfate, it has a charge of +2. Because sulfate has a charge of -2, you can see that on the periodic table. And sort of match that, zinc has to be +2. Oh, oopsie daisy. I don't know how that came about. So in this case, our answer is going to be from 0 to 2+. Choice 1. Now, if you want a further breakdown of how zinc is 2+ on zinc SO4, you can look at the reference table to see that zinc is only +2 on the reference table. Or you could think about it this way. Zinc here is +2, SO4 is -2, and those two have to balance each other out. Okay. Number 11. Given the balance equation, the water molecule acts as a base. Okay, so we're looking at the alternate theory. Because this can tell us how water can act as an acid or a base. So this goes into the definition of the alternate theory of acids and bases. So the acid donates the proton, base accepts the proton. So in this case, if water acts as a base, it's because it accepts H+. If you mention anything with OH- with base, then you're thinking Arrhenius theory, and that's something to also remember to be able to differentiate alternate theory versus Arrhenius theory. Okay, number 12. What occurs when chromium 3+ ions are reduced to chromium 2+ ions? And they gave you a key word there, reduced. So we're looking at reduction. Reduction is a gain of electrons. If you're in my class, you use Lioger. If you're in other classes, you might use oil rig. But I'm going to talk about Lioger. So Leo, losing electrons, it's oxidation. Gaining electrons, reduction. Okay, so it's being gained. Electrons are being gained and the oxidation number decreases, become more negative. Whereas Leo, losing electrons for oxidation, makes it more positive. That's higher. So the oxidation number decreases while electrons are being gained. Good. Number 13. Which statement describes an electrolyte? So electrolytes, by definition, conduct electricity. But that's if you dissolve the substance, that electrolyte, in water. ABS. Acid, base, salt. These are all the different types of electrolytes to remember. So an electrolyte conducts electricity if you take these substances and dissolve it in water. So they cannot conduct electricity as solids. That's not choice 1. Cannot conduct electricity as a solid either. So it has to dissolve in water. And it can conduct electricity in its dissolved state. Choice 3. Number 14. Given the reaction, which change will not affect the equilibrium concentrations? So no shift, no change. No change, no shift. In that case, that's adding a catalyst. Catalyst speeds up the rate of reaction, but it doesn't change anything about the concentrations. It's still equilibrium. Increases both rates equally. 15. Here we have a stoppered flask with H2O gas and H2O liquid. So here we have a liquid with some water vapor inside. And what statement describes the system at equilibrium? So this again goes back to number 1, knowing the definition of equilibrium. And so this talks about reaction rates. They're both equal and opposite. Both forward and reverse are equal, while the concentrations are constant. And that's choice 4. The rate of evaporation going to the rate of evaporation going to gas is the same rate of condensation going into liquid. They're equal. Number 16. Which change occurs when CO is oxidized? So this goes back to Leoger. Oxidized means we're losing electrons, and its oxidation number becomes more positive, increasing. So it loses electrons, cross off 1 and 2, and now between 3 and 4, its oxidation number increases to become more positive. Like over here, Leo, losing electrons, oxidation, becomes positive, increase in oxidation number. Okay, number 17. What occurs when the concentration of H2 is increased? Alright, so for number 17, I'm going to do the work over here because I like bigger space. So when concentration of H2 is increased, that's the stress. So our ramp is going to look like this because H2 increases. That's our ramp. So we lift up the side with H2 because it's increasing as the stress. The ramp lifts up on the left side. And now because the ramp is oriented that way, this is a shift right. So it's going to go to the right. We can cross off choice 1 and 2. And now talking about concentrations, these sides will increase and these will decrease. So the equilibrium shifts to the right, while NH3 will increase and NH2 will decrease. And that's choice 3. Talking about N2. N2 will decrease as we shift right. Number 18. According to the Bronsted-Lowry theory. Ooh, Bronsted-Lowry. So here's something for you guys to also take note of. Bronsted-Lowry theory is the same name as the alternate theory of acids and bases. So that means we got to think back to a few minutes ago, to the previous pages, where I wrote out for you what the alternate theory entails. And so acids and bases, who's accepting, who's donating protons. So NH3 in this case, look at NH3. What does it do? It goes from here to NH3 to NH4 plus. In order to be NH4 plus, well, sorry, I had to fix some stuff. It had to gain a proton. That means it accepted, which means it's a base. A base by receiving, it accepted, it gained. Number 19. Which species is being reduced? So when it talks about redox reactions, where we're looking at who's being reduced, who's being oxidized, we're only looking at those on the left side, because these are the ones going through the redox process. One's being oxidized, one's being reduced. So we could cross off stuff on the right side. That means we could cross off choice 3, Br2. And we could also cross off F-, choice 4. So between these guys, who's getting reduced? Who's gaining electrons to be negative? So who's becoming negative? Is it F20 to become 2F minus? Or is it 2Br minus to become Br20? So gaining electrons means we're becoming more negative. We're gaining negative charges. So who gained? It's this guy, F2, because we became more negative. Number 20. Which process involves the transfer of electrons? So when we're gaining or losing, we're thinking redox, oxidation reduction. Neutralization is about acids and bases. Double replacement is not actually an example of a redox. Single replacement is an example of redox. And then sublimation, well, sublimation is talking about phase changes. So it's just choice 3. Number 21. Which term identifies a factor that will shift a chemical equilibrium? So atomic radius has nothing to do with it, and neither does decay mode. But catalyst and temperature, they definitely play a role here for equilibrium. But knowing the difference here of what a catalyst is can actually help us with this question. So catalyst, adding a catalyst actually speeds up the rate of reaction, but it doesn't shift the equilibrium. It has no effect on the equilibrium. It's rather temperature does. If you increase the temperature or decrease the temperature, the reaction is definitely going to shift one way over the other. So that's why it's choice 4. Temperature, pressure, concentration changes, they definitely change the equilibrium shift. But catalyst doesn't. It just speeds it up. Okay, so for number 22, here we have this reaction of SO2 plus O2 goes to SO3 and heat energy. So what we're looking for this question is which change will shift the equilibrium to the right. So that means our ramp has to look like this. The left side goes up and the right side goes down, and everything falls to the right side. Okay, so if we look at each of our choices, increasing temperature lifts up the right side, so instead it's going to be a left shift, so that's not our answer choice. Choice 2, increasing the pressure. So all of these substances are gases, and let's make sure we count up the number of moles on each side. So there's 3 on the left and 2 on the right. Increasing pressure actually lifts up the left side. So in that case, it's actually the correct answer because it's going to shift this way with the ramp looking like that. But let's look at choice 3 and 4 to see why they're not correct. So choice 3, decreasing the amount of SO2, kind of lowers the left side, as does choice 4. Both left sides lower down like that, because we're lowering the amount of SO2 and O2, so that left side lowers, and the ramp shifts, slides everything to the left. Okay, number 23, the pH of a solution is 7. When acid is acid, when acid is acid, oh my god, I don't know what I'm saying. When acid is added, hydronium concentration becomes 100 times more. So it becomes more acidic. What is the pH of the new solution? Okay. So when we lower the pH, it becomes more acidic, whereas bases, they have a higher pH. So when we become more acidic by 100 times more, we are crossing off choices 3 and 4, and now a pH concentration 100 equals to 2 pH units. So we are more acidic by 2 pH units, going from 7, and we got to decrease the pH by 2. That's choice 5. Number 24, which balanced equation represents a redox reaction? So there are a few types of redox reactions. First type is a synthesis reaction. Second type is a decomposition. And the last type is single replacement. Looking at a lot of our choices, choice 1 is double. Choice 2 is kind of a decomposition, so we'll keep that on hold. Choice 3 is a double replacement as well. It's a neutralization, actually. And then choice 4 is an actual single replacement, so hold a second. So between choice 2 and 4, I'm going to go with choice 4, given it's a more convincing type of single replacement. Choice 2 is kind of decomposition, but it's not necessarily compound decomposing into two elements. It's more like one compound breaking down to two different compounds that don't necessarily combine together to make that same one. It's more of a weird rearranging. But I would safely bet with the single replacement for sure. Especially since in choice 2 there's no charge changes. In choice 4 you have a clear element that's going from 0 to +2 and a +1 to 0. So there's a change in oxidation states, which is what we look for in redox reactions. Number 25. Which equation represents the oxidation half-reaction? So we are looking for something that loses electrons because of Leo. Losing electrons, oxidation. So when we lose electrons, we need to see electrons on the right side of the equation. It's like we're releasing electrons. We go from A, we break down away from our electron, so it releases away. So we need to see electrons on the right side of the equation. Let's cross off choice 1, cross off choice 4, and between 2 and 3, we need to find something that also changes our oxidation state to something more positive. And in that case, it's choice 2, because choice 3 becomes more negative, going from positive to 0. Choice 2 is from 0 to positive. That's oxidation. Number 26, the amount of randomness in the atoms is an indication of entropy. Entropy is associated with randomness. Number 27, in which compound does chlorine have the highest oxidation number? Okay. So that means we need to look at each of these. Oxygen is always a -2. And then sodium is always +1. In all of these examples, oxygen is always going to be the negative ion. So the more oxygens you have, the more negative charge you're going to have from the oxygens, which means you're going to need more positives from the chlorine, because sodium is just +1. It's not enough to cancel out that negative charges from oxygen. In that case, if we look at each of our choices, I'm going to go through each of them. Oh, this one's choice 3 and this one's choice 2. Choice 1, Cl is going to have a charge of +1. In choice 2, chlorine is going to have a charge of +3. In choice 3, oxygen is going to have a charge of +5. And for choice 4, Cl is going to have a charge of +7. So it's going to be choice 4. So let me circle that because I won't be able to circle it on the actual paper. Alright, there you go. Alright, final set of questions. Number 28. Based on the results of testing colorless solutions, which indicators based on the results of testing colorless solutions with indicators, which solution is most basic? So we need higher pH. And so looking at each of these indicators, they all have different pH ranges, and they all should turn blue to indicate a higher base pH value. But who will turn blue with the highest pH? That's the thing. Okay. So we're going to go look at table M for the indicators. Bromthiamyl blue is from 6 to 7.6. Brom-Cressel green is 3.8 to 5.4. You can cross off choice 2 because Bromthymol blue would have higher pH over Brom-Cressel green. Litmus is 4.5 to 8.3. You could cross off choice 1 because it's now been beaten by litmus. And thymol blue is from 8 to 9.6. Thymol blue is the highest because you need to go at least 9.6 or higher to definitely get that color change for sure. Number 29, which is the conjugate acid-base pair? The easiest way to find conjugate pairings is to look at which pair looks the most similar. So choice 1 and 2 are definitely not similar. These two go together, and these two go together because they look the most similar in appearance. We can cross off choice 3, and our answer will be choice 4. So to find conjugate pairs, you match up the ones that look the same or the most similar, and then you pick the answer choice that fits it, because that's as simple as they're going to get. And then number 30, which substance is an electrolyte? So I got to think ABS, acid, base, salt. So let's look. Can't be that, can't be that, can't be that. It's got to be choice 4, which you can look on table K, which is the acid table. You could even look table L for the base to sort of compare. And that's it. So definitely take a look at any other content review videos if you're stuck on some content. I definitely also posted links to some Quizlet and GimKit type of review. So take a look at that if you want additional review. But please make sure you try your best to sort of prepare yourself for this IA. It's going to be difficult, but that shouldn't discourage you from trying nonetheless. Okay? But if you have any questions, feel free to email me, and best of luck, everybody.